Hello, my name is Irrelevant.
And my name is also Irrelevant. You see, we aren't here to tell you about our personal lives or get you involved in either of our crazy anecdotes.
That's right. This presentation is strictly meant to review a chapter of our pre-calculus studies, polar graphs.
Well, are you ready to go, Irrelevant?
I am when you are.
Irrelevant.
Polar graphs!
Polar bears? No! Polar graphs!
Let's start off with the basics. This is a polar coordinate system.
Hi there.
As I am sure you all remember, a polar coordinate system is used to mark the positions of an object or fixed point by finding the distance of the fixed point from the pole.
That's my nose.
Yes, and the angle the fixed point makes with the polar axis.
That's my other nose.
Okay. Also, remember that a point on a polar plane is labeled r theta, where r is the distance from the pole to the point, and theta is the angle the point is from the polar axis.
That's right, Irrelevant. Also, points on a polar plane can be labeled 4 different ways based on an angular restriction from negative 360 degrees to positive 360 degrees.
I'll say,
Points, reveal yourselves.
Yo, check it out. I'm point 30 degrees, but I'm also negative 330 degrees. Homies call me negative 2 to 10 degrees. And negative 2, negative 150 degrees there. What? Here's my boy, little Shizzy.
Yo, I'm the 225 degrees, and I'm also 6, negative 135 degrees, negative 6, 45 degrees, and negative 6, negative 315 degrees.
I am the 0.00 degrees.
That's the pole.
Points aren't the only thing you can graph on a polar plane. You can also graph equations.
Like this.
R equals 2.
Or this.
Theta equals 45 degrees.
Don't forget about the classical curves.
Irrelevant.
There's the rose, the lemniscate, the lemethone and cardioid, and the spiral of Archimedes.
Hey, Irrelevant. You don't forget about the graph of the sine and cosine of theta. Remember? The values of r repeat after 180 degrees.
Let's just move on. Jeez.
Sigh. Sigh. Sigh.
Calm down. What does the matter? Irrelevant.
I can't convert between planes. Sigh. Sigh. Sigh.
Just a freshman. Yes, I'm only a freshman. Working on my pre-calculus. I cannot convert from argon to polar. And that's why I'm making such a fuss.
But Irrelevant. You aren't even taking pre-calculus.
Oh.
But I can teach you how to convert between planes if you want.
Okay.
All you have to know are a few simple formulas that are derived from the Pythagorean theorem. Basically, when you're converting rectangular coordinates to polar, the x-coordinate of a point in the rectangular plane is equal to r times the cosine of theta and the y-coordinate of a point in the rectangular plane is equal to r times the sine of theta. Now, when you're converting from polar to rectangular, r equals the square root of x squared plus y squared, and theta equals the arctangent of y divided by x when x is greater than 0, but when x is less than 0, theta equals the arctangent of y divided by x plus pi.
Math. Eureka! I can convert from arcane to polar. Go ahead, ask me anything.
Why don't you try helping? Irrelevant. Using degrees, name 3 other ways to represent the point B at 3.5 150 degrees with restrictions from negative 360 degrees to positive 360 degrees.
I got it.
Next, find the polar coordinates of the point 6, 4.
We did it! Okay, I got polar planes, but what is this? I don't get it.
Just listen to us, irrelevant. I am trying to explain this to I.
Do you mean you?
Correct. I forgot.
I am I. I am the square root of -1.
That's impossible. There's no such thing as a square root of a negative.
What do you call this?
Whoa!
That's crazy. Hey, is it true that you can be multiplied by yourself to make real and imaginary numbers?
That is correct. I and me is -1. I and me is negative I. And I and me is 1.
Hey, aren't you from that complex plane?
That's what I heard.
Is that where imaginary and real numbers get busy?
I see you've been studying.
Yeah. Complex numbers are the summation of real and imaginary parts in the form a plus bi, where a and b are real numbers and I is an imaginary unit. A plus bi is said to be in rectangular form, with a being the real part and b being the imaginary part. Graphing on a complex plane is similar to graphing on the arcane plane, but instead of x you have a, and instead of y you have bi.
Is that the abridged version?
That is correct.
Looks like
Irrelevant.
caught eye fever.
I believe it is so.
Okay, so I get I now, but how exactly do you convert from complex to polar? What do you have to say, I?
That is correct.
How about I explain? It's easy. Since a and b on the complex plane act as x and y, respectively, on the arcane plane, all you have to do is use the same conversion formulas that we showed you before, with a and b instead of x and y.
Time for another quick quiz. Simplify I to the power of 49. Express in polar form. -5 plus 3i.
Well, that's all for today's show. What was your favorite part? I like that part too.
My favorite part was when...
Yeah, I like that part too. But now we're done.